I just wanted to say that we have a tentative date set for our next event. We are looking to do that event in March, probably towards the end, so just after March break. And once that's all confirmed, we will send all the information out to everybody so you have the details surrounding that event. We are looking at the topic of discussion for that event. We'll be talking about Hyperledger and blockchain, how it's used in today's supply chain industry. What we will have some guests who are from the industry, and they will be speaking to us and giving us their insights and perspective about that topic. Just another second part of this is I just wanted to say is that if there are some members, some people here tonight, guests who are not members. If you are interested in becoming a member, please see me at the end of the night, and I will get you the information that you need so we can get you signed up and registered and signed up so you can get the information for the next event and any other information that's for Hyperledger Foundation and Hyperledger that's new that you guys may want to be interested in other events. So for tonight, what we'll do before we get started, I will go through some slides just real quick for anyone who is new here. Just a bit of an overview, a quick overview of Hyperledger. And you can have a look up here and you can go through it together. Get this.
Sorry, you want to take the screen up there? Change screen?
Yeah.
Good.
Okay, so here is Hyperledger Foundation. Hyperledger Foundation is an open source community focused on developing a suite of stable frameworks, tools, and libraries for enterprise-grade blockchain deployments. It is a global collaboration hosted by the Linux Foundation and includes leaders in finance, banking, Internet of Things, supply chains, and manufacturing and technology. Sorry about that. Here are some of the foundation's goals. You can have a look at them here and just quickly glance at them, and you can see. And I'll go to the next slide. Here are some of the Hyperledger blockchain technologies for business. They are the graduated Hyperledger projects. I think most of you should be familiar or have seen Hyperledger Fabric. That is the one that we will be discussing tonight in our talk. And then here are the incubating Hyperledger projects. And again, you probably noticed or seen Hyperledger Firefly and Hyperledger Caliper. So here are some of the other ones that are incubating. And we'll move forward. And here is all the information if you need. There's a website. If there's any information that you need, you want to go on, you want to download, you want to see, you want to read, you can go on, browse onto here and get all the information that you require. Again, I'll leave that up. And also at the end of the night, if you are interested in the PDF, I can send one out for you that you can have that for the reference, and you can also have all the information that's on it. So let's, Sukhpreet, are you ready? So I'll introduce you to Sukhpreet Singh. He's the CEO of Gyan Consulting, and he will be discussing tonight the topic that we mentioned. So ready?
First week. No, you have this. You have to share this one here. Take a look at this. Which slide is it? No, here, take yours. Take your screen. Take the laptop. Yeah. Now this is your screen. I'll put it up there, but you need to. I'll put it up there. Just go ahead and share it. I mean, just go ahead and start playing it. Yeah.
How you guys doing?
So I the hiccups, things becoming virtual and live. First, I was going to talk about Sukhpreet Singh, CEO of the Gyan Solutions, a little bit of information about the company. Pretty much we're IT and IT consulting and software company. I keep this short because I know we'll come late. A little bit of information about myself is that I've been an entrepreneur and have 10 years experience in the IT industry. I currently specialize in digital transformation and enterprise blockchain. My passion is just in technology. Okay, so what we're going to do is, we're going to talk. Originally, what we're going to do is we're going to talk about blockchain and Hyperledger in terms of more of I guess, non-technical perspective for for enterprise use. But in order to explain it fully, I thought that we need to go through the basics of the architectural design, and then we could probably move into more of a comprehensive discussion, such as why should we use blockchain, should we use blockchains, and failing problems, so on and so forth. So hopefully by the end of this presentation, you guys have a better understanding of the topics that we're talking about. So quickly we're going to go through what is blockchain. I know most of you guys know. I'm just going to go quickly through the blockchain. For those that don't know. Blockchain is pretty much it's a transactions that are blocked together and are pretty much referring to the previous block. So all the transactions are hashed. So let's quickly go through this. What is a hash? It's just a data set that's transferred into a single string that contains our numeric or other characters. So for example, you take that and we hash it, you're going to get this hash. If you take the same word and just put uppercase, believe it or not, it changes the hash. So we understand that any type of data change in characters or anything will change the hash. So now we're going to go to this. So we're going to go to the blockchain. So first you have the Genesis block, and that's the first block. And what the first block was going to happen is that it's going to have a hash. The next block is going to have a bunch of transactions that are going to be grouped together and hashed. And that hash is going to be evident for that. So that has to be that block. And then you're going to refer to the previous block. The next is that you're going to have exact again. You're going to have another bunch of transactions that are going to be blocked again. That's going to be hashed again. And it's going to refer to the previous block. If, for example, one of the transactions in the block, one transaction in the block was changed or compromised, you'll notice that the block hash had changed. And so if you look at the previous block, you'll notice that it doesn't match. So you obviously know that it has been compromised. Yeah, and also that it's been compromised behind this. So next smart contract, I think everyone knows what a smart contract is. It's pretty much just a contract that's digitalized. Identifies the agreement, sets the conditions, code, business logic, and pretty much is loaded to the blockchain where it's used to encode business logic. So now, the second part of it is the distributed ledger. So pretty much what happens is that every node or participant in that blockchain is going to have a copy of that blockchain, the database of that ledger. So what's going to happen is that anytime the consensus is met, it's going to change the ledger and also the state. What's going to happen is that's going to be synchronized with all the ledgers in the system. Well, blockchain can be put to blockchains. We can go through this. First is permission blockchain, which you can refer as to cryptocurrency. Anyone has access to it, and all the information is public. The second one is private permission. This is customized blockchain. Here, it's all the access control. You have to have permission in order to join the blockchain. Then we have the hybrid, which is obviously the combination of the two. Yeah. So now what we're going to do is we're just going to go into a brief about the Hyperledger. Currently, the reason why we're talking about Hyperledger Fabric is because right now it's kind of known as the most mature blockchain that there is, and also the most popular currently that's used in enterprises. So first, we're going to talk about the CA. Every organization in the blockchain is issued a digital certificate. With that digital certificate, what happens is that that's pretty much your authority. It has public key and your private keys. With that information, an organization is able to communicate to the network. The second part is the MSPs. The MSPs pretty much defines the access to the different parts, the access to the different parts of the network. So if you look at the Hyperledger Fabric documents, you can pretty much compare the two as the CA being credit cards, American Express, MasterCard, and Visa. And you can think of the MSP as the merchant. Not all merchants take American Express, although American Express is a valid card, but yet it's not accepted at that merchant. So you can kind of all of that comparison. The next part is channel configuration. So the configuration of the network is usually done through this, and also you can do other administrative tasks. Another thing is that's very important is policies. The policies are pretty much used. These are conditions that are predefined that ultimately decide whether the transaction will be valid or not. Channels is pretty much a mode of communications, and also they can be isolated. So different organizations could join different channels in order to communicate. The ordering node, obviously that's the consensus. So in order to have a valid transaction, the consensus would actually validate that transaction, and therefore submit it to the ledger. So peer nodes, actually this is very important. Every organization has its own peers. The peers are pretty much used for validating transactions, maintaining the state ledger, and communicating with the rest of the network. Also holds the smart contracts. And the last one we have is the smart contracts. I think we all know what that is. It plays a major role in here. So in Fabric, that we call smart contracts chain code. And so with this, what happens is that this chain code allows to validate other transactions, update the ledger, and create the data. And the last part is the ledger. So we have to understand in Fabric, the ledger is actually composed of two things. It's actually composed of the state and the blockchain. But if you look at the state over there, the state is a current state value of the blockchain. That can always change. And the blockchain is actually all the transactions that have been performed, whether they've been valid or not, and that is immutable, that doesn't change. Okay, so the next part we're going to go into. Before I go into explaining all of the information, what we're going to do is pretty much explain which the icons we represent. The reason why I use the Hyperledger Fabric images is that when you yourself go and try to read the documentation, information, you kind of you have a better feeling, better understanding if the diagrams match. Okay, so what we're going to do first is that if you notice the CA1 pretty much, notice all of them are purple. So pretty much representing that all organization one is going to be represented. Oh, sorry.
Right.
Okay, yeah. So all the purples represent one organization. So you notice that you have the C's over there, the digital certificates. The P1 actually represents the peers, and A1 actually represents the application. We'll get into what the application is a little bit. You notice obviously you notice all the organization 2 is represented by the other color. O is the consensus, which is the order, and we have it, which is one of the form file, which is the channel configuration at the bottom over here, and we have C for the channel. And obviously, everyone that's on the channel is also going to have the ledger. They're going to have a ledger present, so we have access to the ledger. Right. Also, I want to explain one thing about the A1. A1 is actually representative of the application from the client side. So that's actually, for example, the ERP system of the existing companies. For example, Walmart, they're actually going to use their own ERP system, and they're going to use right here. You'll see here there's going to be an SDK Fabric. Fabric SDK, which allows them to communicate with the network. Right. So we're going to go a little bit more. So how do you create the network? So the first thing to do to create a network is that what you do is that you create the configuration channel. With this configuration channel, what it's called is called crypto config tx YAML file. Within that file, what you're going to do is you're going to list all the organization. You're going to list the MSP directory. Also, what you're going to do is you're going to put in the policies, and you're going to say the direction of where the order is. The other two files that has been used for the configuration is going to be the order YAML file, which gives the configuration for the order, and the peer configuration, which is the core.yaml file. So, one I want to say another thing. In here, in essence, what happens is before configuration is actually launched, what's going to happen is that all the organizations are going to get together and they're going to decide pretty much the policies, how the policies of the endorsement policies, the community policies, and also any other configuration policies that are needed to run this channel. So next, after that, what's going to happen is that what happens is that the admin is going to initiate or is going to create the channel. Once the channel is created, it's going to add the orderer and the two peers, right? After that, you notice that all the peers and the orderer have a copy of the ledger. Oh, one thing I forgot to tell you, if you go prior to this, what we say in here. What I've noticed is a lot of currently, there's examples of creating the CAs. A lot of people notice that they use CryptoGen in order to create the CAs. However, Yevlin said that that is actually a test environment. What the best thing to do is to actually use the Fabric CA or any other CFR that you can use. That is the most best and secure way to do it. Okay, the next part is we're going to launch. We're going to launch the smart contracts to the different peers. This could be done, the CLI, but that's not necessarily recommended. It's recommended to actually have the applications, integrated and through the SDK to actually have it to post the contract on the peers. Yeah. If you want to add a channel, right? So what happens is that if you want to add a channel, what's going to happen is that you're going to have to create another channel configuration. And it's pretty much the same process that we saw before. What's going to happen is in that file, you're going to have to pretty much list all the organizations that are going to be in there, all the policies, and also the list of the directory of the MSPs. If you notice, after that, we're going to create the channel again, and we're going to add the peers. If you notice in this channel currently, what has happened is that we have P3 and P2, which is organization 3 and 2. They're connected to the channel. If you look at this, they're the only ones that have been able to communicate within that channel. Notice that P1 is not within this channel. So what happens in essence, P1 or organization 1 has no access to that, nor can they read the ledger. And you notice at the top, P1 and P2, they'll have L1 and L1, which is representative of channel 1. What is O? O is the order, right? So O is the order, which is the consensus, right? And if you notice that the order is actually connected to both channel 1 and channel 2. Okay, and so when you notice that P2 has L1 and L2, what that means is that it has the ledger of the channel 1 and channel 2. Okay. Also, if you notice, keep this in mind at the end of the presentation because I'm going to bring it up again. Notice the order has both ledgers, right? So it's able to have both ledgers. But also take another thing is that the only way there is another way, get to later, but the only way to query the ledger is if you have a smart contract, right? So that's one. Okay. So now, say for example, you want to add organization 3 to channel 1. So what's going to happen is you're going to have to change the configuration for channel configuration 1. So you have to go into the config tx file, and you're going to have to add that organization to that channel, right? Once that's added to the channel, then what organization 3 is going to do is going to, through the SDK, is going to launch the smart contract, which is on the next one, to its peer. Now, officially, P3, which is organization 3, has access to both C1 channel 1 and channel 2. However, notice that organization 1 still only has access to C1. So they don't have any communication here, nor do they have any access rights to here or see any of the information. Okay. So the transfer, how does these transfers actually occur? So what happens is the real application. go through your application, what's happening is that.
Leave your mic.
Oh, sorry. Yeah, so what's happening is that through the, for example, A1, organization one, if they want to propose a transaction, they're gonna do the SDK, they're gonna invoke a transaction with a smart contract. And what's gonna happen is that that transaction is going to be sent to all the peers in the network. So what's gonna happen is that that transaction is gonna be sent to peer one, peer two and peer three. What peer one and peer two, three is gonna do is they're gonna endorse it. What they're gonna do is they're gonna check the chain code and also the endorsement policies of that chain code. They're gonna, and also gonna check the ledger to see if all the information is valid. If the information is valid, they're going to sign it with a digital signature and send it back to the application. The application is going to receive all the rewrite files from P2 and P3, right? Then it's going to take that information and it's going to give the order services. Once the order services receives that information, again, it's going to check the endorsement policies and it's going to check whether these transactions are valid or not. But remember, at this stage, they're only checking the information from just the chain code side. Once that they validate that, they're going to block information and then they're going to submit it to the committing peers. One thing is, don't think of the committing peers and the endorsement peers of two different entities. Peers have multi, responsibility. So in essence, it could be the same thing. So now what's happening is that now those transactions are sent to the committing peers. Once it's sent to the committing peers, what's happening is that they're going to be checking the endorsement policies, the ledger. And what they're going to be doing is they're going to see, for example, endorsement policies. For example, if that transaction needed the signature from peer 1, 2, and 3, what's going to happen is that since it has all the signatures, within that block, it's going to check, okay, does it have the 3 signatures, right? And it's also going to check against the general policies, so on and so forth. Then what's going to happen is it's going to tell them whether it's valid or not, and it's going to send it to the ordering service. The ordering service is again going to check whether that if it meets the policies, whether it has significant signatures. If so, what's going to happen is that it's going to send it to blockchain. Once it's sent to the blockchain, it's going to be distributed to all the nodes, and the blockchain is going to be updated. Yep. So now we're going to go. We have any questions about that or no? Okay. All right. So now what's going to happen is that we're going to talk a little bit about the benefits of Hyperledger. So obviously, there's a lot of benefits. Some of them are that it's transparent, it's mutable, it has a lot of security and reduced costs. Good. So we're going to quickly go through this to kind of reinforce it. Obviously, it's immutable because of the hashing, right? Any information that has been changed is going to change the hashing, and then obviously it's going to be compromised. And then obviously adding onto the distributed ledger is very difficult to have pretty much compromised information because all the nodes and all the participators are always going to have the latest and updated ledger. Okay, transparency. How is it transparent? Through the endorsement policies. You have to remember, before creating the channels, all the organizations have to agree upon the policies that they're going to have. So these policies are actually universal, regardless of what organization it is or not. So it doesn't matter if organization 1, 2, or 3, there's no special treatment for either or of them. The predetermined conditions have to be met. Okay. Second part is security. Why is it secure? Because everything's access control. Any information you want to get, whether if you want to get into a channel, whether if you want to get a channel, if you want to query the ledger, everything's access control. Without access control, you're not going to be able to get the information. And encryption. This is a very important part because all the transactions are encrypted, right? So, for example, a hacker, it's very difficult for a hacker to get in because all the transactions are encrypted. So all the organization, any transactions that they do, they have to sign off with their CAs, the private key and public key. And so if we forget about hackers, even if we have, I guess you can't show it, but if you're not a part of that channel, you're not even able to see the information because the encryption, right? So it's very secure because of the encryption. Okay. The part is transparency, security, immutability. So this is obviously to the consensus we talked about before. Since the consensus, as I said, it follows the protocols, it's endorsing policies. Again, it's all universal. So no organization is going to have a special treatment for the other organization. Security and immutability. Reason why is that because anytime when they validate the transaction, it's going to be sent to the ledger, and all the peers are going to have the same ledger. So it's a very secure. Another part is the private data for security. Sometimes within a channel, sometimes organizations want to communicate with each other. So and they want to pretty much not withhold, but they want to keep withhold confidential information. In that situation, you can use private data, which is the private data collection. So pretty much the information is going to be encrypted, right? And the only people that can receive it, for example, will be peer 1 and peer 2. On the ledger, you'll be able to see the information, but the information that peer 1 and peer 2 or organization 1 and 2 wanted to encrypt or to hide would be encrypted in the private data. So although you're in the same organization, for example, organization 1, 2, and 3, although organization 3 is in the same channel as the other two, yet it won't have access to that data because it's encrypted through the private data. Then also we have security. We won't go too much into this, but everything runs through smart contracts or smart code or a chain code. And so whether you want to query the data, whether you want to post a transaction, has to go through chain code. And all the chain code is also related to the digital certificates. So what benefits do companies have? It reduces costs. Why? Because automation. Anytime you automate something, obviously you're going to spend time on time, which obviously spending time.
There's some questions.
That's a question. Okay. Sorry, hold on. Okay, yes. Yeah, so if you want,
Let's take a look here. What is the O? And then after that, is there an integration platform similar to MuleSoft WebSphere that can be used to develop and manage Hyperledger components within the enterprise? And can I see this getting, and I can see this getting messy as group of enterprises adopt it?
to tell you the truth, I'm not too familiar with those projects right now. I guess in the works, there's different projects that we have. But to tell you, I'm not too aware of those.
Are there any tools to help and deploy and manage networks?
That's just given.
Okay.
Okay. Where's that?
Can chain code be updated? Is it different from smart contract in the public one that can be that can't be updated?
Well, yeah, chain code can be updated. So the process of that, what's going to happen is that when the chain code is updated, it has to ultimately have to meet the what's called. It's going to have ultimately meet the endorsement policies. So it really depends. Okay. So now from a development perspective, it really depends upon your configurations, right? So in the configurations, you might outline, well, it can and cannot be changed, or it can be changed, or it can be changed by organization 1 or 2 or 3, or whatever information it is, but it can be changed. But however, any change to the smart contract has to be validated by all the peers. Did I answer the question, or?
That replied, so hopefully.
Ask you a question.
Yeah,
So if I sign and you sign and I have bilateral communications contract, why do you need to have a consultant for? Because we already signed.
Well, the problem is that we don't know, we can't trust each other. I don't know who you are.
But you have a CA here.
But no, wait, ask the question again.
So I'm organization 1 and the organization 3. So we have a subsidies, trusted. So everything is connected. There is a main CA that we get it like everything. Like subsidy information from, so the trust is common.
So you know what's done, I'll continue to be here.
The question is really simple. So in untrusted environment, so the chain itself works as a certificate. So I have a private key, no one knows it's my private key. Public. However, here I have a C1, C2, and even the root CA that I use subsidy. And the question, like, if I have a trusted certificate, and you put trusted certificate, and we know each other, why do we have a consensus for?
The CAs are just means of communication, right? So what's gonna happen is that you have to remember.
I
Just
guess
because-
CA means X 5.9 certificate.
Yes, but remember, you have a CA, all that means is you have a public key and private key. Pretty much that's, you have a public key and private key, you're just able to prove you are who you are, right? However, in channel one, if you're not included in that MSP, you're not able to get into that channel. Right, so that has to be, so for any time when you try to enter that channel, you will get rejected. Why? Because the endorsement policy will first check, are you a part of that channel? Right? Because the endorsement policy is going to specify the MSPs. So for example, you try to even create the ledger or whatever it is, you're going to get rejected because you're not in the endorsement policies, nor are you the MSP. It's access control. Do you get what I'm saying or no?
Yes, but like my question, is not from the business.
Okay.
So I have a trusted certificate, and you have a trusted certificate. Can I trust you? Can you trust me? So would it be sufficient to have we just sign the document, the message? And transmit it?
Would you using blockchain or just physically signing it?
Does it matter?
Yes, no, it does. Because you have to.
That's what my question.
Oh, sorry, yeah. So why, is your question, why are we using CAs?
Yeah, like, if you use a certificate authority, means like, we trusted each other. Because, right, I'm trusting your certificate authority, you trust my.
You don't need to trust me. It's trustless. So what's happening is that we don't need to trust each other. So what's gonna happen is that we're gonna, for example, we're gonna outline, for example, if there's a transaction, right? For example, what are the transactions? We're gonna, in our policies, we're gonna say, in order for that transaction to be validated, we need organization 1, 2, and 3 to sign off, right? Now, how do I know you're gonna be honest or not? It doesn't matter. Because what's gonna happen is that when you propose, I'll go back to, if you see this, when you propose the transactions is gonna be sent to all peers, right? There's no need for trust. So what's going to happen is that, remember, we've also agreed upon the smart contract. So for example, we have a smart contract. I'm going to sell you a product for 50 cents, right? Now that smart contract has been agreed upon. That can't be changed, right? How does that be agreed upon? Because that was proposed, that was accepted, and now that's on the ledger, right? So if you were to try to change that information, for example, we're going to exchange a car for $5 or a product for $5. If you're trying to put it, okay, now it's $2, it's going to get rejected. Why is it going to get rejected? Because if we look on the ledger and we look at that chain code, in that chain code, that number is actually $5. You get it? So there's no need for us to trust it.
But from the business perspective, so we agreed on $5 and we co-signed it. We said enterprise.
But when you say co-sign, but like that's what I'm saying. When you say co-sign, we need to
every time you transact with a chain, you need to sign it. With a trusted private key, so I can obviously trust certificate. Right?
Yeah, but what I'm saying, but we don't need in this, that's what I'm saying. I understand what you're saying, but when you're saying we trust, how do we trust?
So the certificate authority.
The certificate authority doesn't do anything. What if the policy says something else? So what if the policy says, for that transaction, what if the policy says that we need 3 signatures?
Okay, that's fine.
So that, but you understand, if in that policies, remember this, if in the policies it says we only need 1 signature, then in theory, what you can do is you can propose anything that's going to get to the ledger. Right? There's no consensus.
You see, my point is like, we deal with organizations with a trust. So, right, working. But what's the point of using certificate?
No, the reason why you use certificates is that you're pretty much signing, I was gonna get to the later, the later slides. But what happens with the CA is that everything's transparent. Anything that you do will be seen. Whether you endorse, you do a transaction or anything you do, whether it's you're endorsing or committing, everything is put on the ledger. Get it? So if you do a transaction, you're gonna know exactly who did that. How are you gonna know who did that? Is through your CA. So there can't be a transaction saying, well, I didn't do it, organization two did it. No, because you're the only one that has those digital certificates. It's impossible for anyone else to sign for that digital, anyone else to sign on your behalf. Get it?
Right, but for instance, I can give you an example. I go to the bank, I just sign in the print. And banks say, sign this agreement, which is like, the private key that belongs to the certain department. But when I go to a chain, I can see that like a trust certificate, or certificate, the bank itself. Why couldn't they trust the bank? The root certificate. So.
No, but that's just not, that certificate is just authenticating that you are who you are. That's all it's really doing.
Right.
So for example, we're gonna have me for there's three organizations, right? There's three people, right? And me, you and John, right? We all
That's
said,
not how it works in organization.
how's
In
that?
organization, you don't work for yourself. You work for your CEO. So meaning like, all this kind of certificate would be like, basically the only person who's actually responsible for everything is your CEO. Right, your CEO.
No, see, I think what you're saying. So you're saying that the information, if you're talking about the information that's sent to the organization, well, that has nothing to do with necessarily with the Hyperledger. That's on the governance of that SDK. So for example, that our ERP, for example, from the ERP system, right? You're gonna submit a transaction. Well, Hyperledger has nothing to do with your ERP system. That access control is on your side of who can sign off and who can sign, whether they're a general laborer signing off or a CEO, right? That has to be done pretty much on your side. Because remember, if a general laborer or someone, if anyone gets access to your system and pretty much getting access to your to ERP and submitting the information to the SDK, that's pretty much on your side. Get it? Because that access control is on your side. Fabric cannot be responsible for your security on your side. Do you get that or no? For example, if you integrate with SAP, right? If someone, SAP secures your information, right? But if someone gets your password and they go in and they change it, well, that's the organization's fault. That's not SAP's fault. You can't say, well, SAP, why did you do that transition? You have to take that back. No, well, your password got compromised because of your organization and your governance and your security structure. You get that or not?
There's no password in organization. Organization, like
Pardon?
you can make a password, but like an enterprise, you always have an agent. You always have a security control, unless it's a small company.
I think we'll talk about it, but I think we're talking about two totally different things there. Because all the CAs does, it just certifies that is it. All the CAs does is just certify that you are who you are, right? That's pretty much all it does, right? And pretty much, but with that, it doesn't mean that you can join any channel, right? You get a sense. So just because you certified you are who you are, right? But it doesn't mean that you have access to everything in the ledger. It's just saying that when the policies that the same organization has this access and that access, well then you're able to pretty much transact on those rules because you are who you are. Do you understand that or no? We'll get to the next one. Okay, so yeah, so what we'll do is now we're going to get into, speed it up a little bit. So now what we're going to do is we're going to get into for a company, for example, why do we need blockchain? A lot of companies think that, okay, this is great, blockchain is great, it can do everything for us and so on and so forth. But the first question you have to ask yourself is do I even need a blockchain? Right? It's not always the situation. So for example, if your centralized database is actually doing what it's supposed to, it's handling security efficiently, then would you really need a blockchain at this point in time? Another thing is that if you guys, I think what you're talking about, if you have trust, for example, in your centralized system, you have trust with your accountant or whoever it is. If you trust that person, then there would be no need for a blockchain because you have that trust with that person. Also, another thing is that if you don't have any regulatory compliance with data storage, then you wouldn't necessarily need it. What I mean by this is that, for example, take the pharmacy industry. All the data, everything that they have to back that up. They have to prove that it is what it is, and they record it at that time, and so on and so forth. So there has to be some sort of system in place that shows that their data is accurate. If that is a situation, then blockchain will probably be the best situation because since everyone's sharing the same ledger, you can actually, in third parties, you can actually prove that yes, the information that you did submit is correct. All right, why you may need a blockchain, obviously, if you want to remove the intermediaries or brokers. Another thing is that if you want permanent data set, another thing is if you want a permanent records. For example, if you take example for medical, right? Medical, what happens that there might have been mistreatment or misdiagnosed or something that has to do with it. And so what a doctor or a hospital, what they might do in order to, I guess, avoid any legal consequences, what they might do is they might compromise the data and change it so that there's no legal repercussions. But if you have a blockchain, it's very difficult for them to do that, right? Because of the distributed ledger, they don't have that central access, and they're not able to do any, they're only able to do read and writes. They're not able to change the data or delete it. Pretty much we're going to the other things that you need shared access. So with the shared access, a lot of times two companies need to share information. So in that situation, you're either going to use the third party, which is centralized, or one of the two organizations is going to host the data. In that situation, again, what's happening is that is centralization of data, right? You have to trust the other person. But in blockchain, since it's a shared ledger, you don't necessarily need to trust that person because it's blockchain that's going to pretty much use the consensus to validate those transactions. Digital business require high performance prevents high performance transactions. So that's pretty much saying that the complexity of it. If there's a lot of complexity and there's a lot of components that you need, then blockchain is probably something that you want to look to. And the last one, if you want to have trust between the contributors. Okay. So now we've decided that, okay, you know what? Now we've decided that, hey, blockchain is great. We want to do this. Now, what are the steps to move forward? The first thing what we have to understand is that there's no such thing as a blockchain developer that will build your blockchain. For some strange reason, we think that there's one person that can do everything for us, right? If we look at traditionally, anytime we're about to launch a product or build anything, you'll notice by this jargon, there's a lot of pieces that are in there. There's a lot of positions, a lot of expertise, and so on and so forth, in order to get a product launched properly and successfully. But with blockchain, for some strange reason, we think that all of these positions can be covered with a single blockchain developer. No, that's not the situation. Right? So building a blockchain is just like any other program. You're building a blockchain, you got to gather information. And if you notice here, before building a blockchain, there's a lot of non-technical things, such as gathering information, identifying the scope of the project. These are more or less non-technical aspects that within the company, a CEO has to make decisions of how this governance is going to happen. Also identify any constraints, legal requirements. Sometimes the transfer of the data, or how you transfer the data, or how you interact with other companies and what information you need. Ultimately, those are our legal compliances. So that has to be developed by pretty much experts. Another part is designing the architectural design. That is, I guess, somewhat semi-technical, but at the end of the day, we have to understand, before we start developing anything, we have to understand what we're developing, what is the architectural design. And again, how this usually happens is that there's either a consultant hired to answer these questions, or what's happened is that you hire people in your company to get these tasks done and completed. But again, what's happening in blockchain is that we're asking that developer to tell us what to do and what to shouldn't do, right? For example, for the governments, and we're talking about the policies, you're relying on the blockchain developer to tell you, okay, well, what are the governances, what can happen, and what not, and so on and so forth. For example, is there any DevOps here or server admins? I don't know. There is, but for example, if you were to ask a server admin, if a full stack developer or a software engineer, would you trust them with their task of launching the servers or configuring the servers? Not necessarily. It's not that he is not competent to do, but he just doesn't have the expertise. So it's the same thing for blockchain. There has to be, every position has to have the expertise and knowledge. We can't depend upon just one person to do everything in the blockchain. All right. So another thing, if we don't want to build our own blockchain, what we can do is we can join an existing blockchain. So, for example, this blockchain here, there is an admin of this blockchain. You can be an admin of the blockchain that is not an organization, or you can be an organization. However, in order to maintain this network, what we talked about previously, there's a lot of moving parts, a lot of different positions, and a lot of things that have to be considered in order to launch, configure, and govern that blockchain. However, if you just want to join a blockchain, you might not need as many positions. So for the first thing is obviously you're going to need to host the peer on your own node, right? Obviously, you're going to need a server admin for that, and then also probably you're going to need a blockchain or front-end software engineer to actually use the SDKs in order to integrate with the network. But again, this is not an exhaustive list. What might happen is that, for example, there might be a smart contract or a governance policy. And so what can happen is the front-end developer or the blockchain developer can take the machine language and turn it into readable language, which then can be given to another expert, for example, a CEO or a lawyer or an architect, and they can further inspect it and say, well, yes, this governance is within our business logic, or so on and so forth. So when joining a network is not as as intense as hosting their own network. Okay. Now, if you're not noticed, lately what's happening is a lot of people saying, well, blockchain has failed, right? And there's blockchains that projects have failed, and there's a lot of things that are going on with the blockchain industry. And even the critics of blockchain will say, hey, I told you, this technology is, it's not there, it doesn't do what we don't need this technology. But you have to understand most of these. Okay, so you have to understand that most of the problems have nothing to do with the technology. It's actually the implementation of the technology. I'm going to get into this further. Right? For example, lack of clear use. For example, I know one situation, an entity, what they did was, there was a single entity company. What they did is they launched a blockchain. They thought it'd be a great idea because all of the automation and so on and so forth, immutability and so on and so forth. And what they did was that for the CAs and organizations, for every department, what they did was for every department, what they did was they issued a CA for every department. That's great. But the mistake that they made is that if you not notice, everything was obviously on one machine. So what they did was they actually used Docker. Obviously, what Docker does is that you're able to isolate different environments onto one machine, right? So yes, you have your peers, right? You have your order services, so on and so forth, and everything, right? So you're going to have your transactions, you're going to have your policies. But the one problem is that there's only one IT team managing this. Even though we have different nodes, the access to this server admin is one access, and the developers are one team. So at any point in time, it can be compromised. If we were to even separate this on a different server, or we would have these nodes on a different server, we will still have the same problem. Why? Because we still have the single IT team that has access to all the data. So although it's a blockchain, this situation is more or less a centralized blockchain because everyone that's controlling the servers that have access to the information is just one entity. Another problem is that for industries where players lack technical infrastructure, right? So a lot of times what happens is that there will be apps made or platforms made for industries that seems great, seems like a great use case situation. For example, construction. In construction, there's many moving parts. There's a plumber, there's a house builder, there's certifications and so on and so forth. So in theory, that's it's a great industry to use blockchain because you're going to be able to automate the systems. You don't need to have trust with each other and so on and so forth. So if you really look at it, well, hey, you know what? You should do a blockchain. But I have a question. If you ever see in the construction industry, they're still using pen and paper, right? So if they're still using pen and paper, how do you expect them to create an infrastructure or create their own IT team to use the platform? They're just not going to do it. So although the ideas are great and it could be used, but the question is the infrastructure there for them?
May I have your attention, please? It is now 8 p.m. and the library will close in 30 minutes. If you need to register for a library card or update your current library collectible materials, please do so now at the customer service desk on the first floor. Please return all reference materials to the floors from which they were borrowed. Reference materials are for use in the library only. If you're using a wireless service, please end your session in 25 minutes time at 8:25. Once again, the library is closing in 30 minutes at 8:30 p.m. Thank you.
Okay, so we're going to talk about the next part is that a lot of people say, well, there's no speed, right? There's a speed problem with this. But we have to understand it comes back to the numbers. So for example, if you have a blockchain, for example, you have for example, UPS, and what you want to do is you want to scan a package. Well, when you scan the package, you can use a third party, right? When you're using a third party, that's kind of it's kind of an unbiased information. So when you scan the package, do you really need all the entities to sign off? And when you have all the entities signing off, peer 1, 2, and 3, you have to understand that's going to take time, right? The peers might not be available, right? It might take time. So people complaining about the speed, well, we have to understand, well, in our configuration, how can we configure it? Where do we need these signatures? And how can we speed up the process, right? Also, the other problem is the architectural design. We have to understand again, it's how we develop the blockchain, right? It doesn't make any sense. It doesn't make any sense to make it more complicated or add policies that we don't necessarily need. And it comes back to what we talked about before, is that you cannot depend upon a blockchain developer to tell you all this information. All of this has to be pretty much scoped out prior to building the blockchain. Good. Last people think is they complain about scalability. The biggest misconception of blockchain, in my opinion, is that blockchain is not a database. It is not a database. If you need to use blockchain as a database, you really have to reconsider why you're using the blockchain. First of all, the blockchain, remember, you have different nodes and different peers. Anytime you submit information to the ledger, it's going to be obviously data intense, right? So what's happening is that people are coming, well, it's not scalable, it's not, it's too slow. Well, if you're using data intense information, what the simple solution is, this goes back to the architecture design, is using a distributed file system. Does anyone know what that is? Or so the distributed file system is pretty much pretty much a decentralized database, right? So what's going to happen is, for example, you have a large image or large data, or even a very complex smart contract. Just like it's kind of the same concept of NFTs. Instead of sending it to the blockchain, what you can do is you can send it to the distributed file system, have that information hashed, and then save that hash on the ledger. So what happens is now you're decreasing the amount of data that's on there. So anytime you need to invoke that contract, what's going to happen is it's going to refer back to that database. And how can you make sure that's the same? Well, because that database is distributed well. So whatever that contract is here, whatever hash that it has here, is always going to have the same hash. So it's kind of like the same thing as the distributed ledger, but it's a distributed database. Okay. Other problems is obviously costs, right? Right now it's in its infancy stages, so obviously there's not many developers out there, and also that's going to cost you more, and also lack of standards. Talking about before, we don't know what the standards are, right? We don't know what the best practices are right now, and so because of that, a lot of practices are using the wrong standards, which may actually lead to a failure. Another one I'm going to talk about is, if you guys not noticed lately, there's been a few projects that actually had failed. They've been in production for a few years, and they recently failed. And again, critics were like, "Well, I told you blockchain doesn't work." But we have to understand, what is a blockchain? Blockchain is decentralized, equal rights and decisions, and transparency, right? If we go into those situations of those blockchains that have failed, if we really dig deeper, what was the complaint? The complaints of the organization was that they didn't feel it was decentralized. They didn't feel that they have all the rights. They didn't feel that was transparent. And now you might ask yourself, well, how is this possible, right? You're using blockchain, right? If using blockchain, how can it be possible that there can't be transparency, can't be equal rights, and so on and so forth? Well, that's very easy. Because remember, the admin to this, right, can also be an organization, right? So take for this example, the admin for this blockchain is also organization 1, right? So what's happening is that now what's happening is organization doesn't have access to channel 2, correct? It cannot see the information, correct? Actually, it can, because since organization is the admin, it also has control of the order. And since it has a control of the order, it has the ledger. You get it? So in all actuality, even though it's not a part of this, it can still get the information. And depending how they create the governances that have chain code, they might have installed a smart contract, right? It's difficult to query the data because you need a smart contract, but to the CLI, you can still get information, you can still get data information from that. But then again, we don't know exactly what the governance was, right? In the smart contract, it could have said that, well, the order also is going to have a smart contract. As soon as the order has a smart contract, you can query the database. So for example, P1 can have access to this. So example, we have another peer we added, for example, peer organized 00, they also become the admin, right? What now actually can happen is that now peer 1 and peer 0 will create their own channel, right? The disadvantages in that is that channel will not be seen by anybody, right? But they're going to be able to see everything within the system. So that kind of defeats the purpose of decentralization, right? Another problem that could have happened is the configuration, right? How the configuration, what the policies, and so on and so forth. And it comes back to what I've talked about before, is that these applications should have read all this information, and they should have access to this, understand what the policies is. But because of the lack of information of what the policies are, how the smart contracts work, they're just taken for face value, right? So now, as I said, this is not the technology's fault, it was the governance. So how can this have been solved? Easily, private data, right? We could install private data, right? So although the order, right, has access to the ledger, if it's private data, they're not going to be able to read it without being encrypted. And obviously, if they don't have the authority to encrypt it, you won't have to see the information. The second thing is zero knowledge proof techniques, right? So pretty much you can prove the authenticity of the transaction or the information, but you cannot see the underlying information, right? Also, you can do is a decentralized architecture, which actually can have different nodes for different channels. And then it goes back to what I originally talked about, is necessarily architectural design. So if you notice that the failure of those projects are not necessarily the technology, but how it was governed and how it was created. Pretty much we're coming to the end of the presentation. So pretty much what do I see in future adoption of blockchain? Just like any technology, it takes time. As for example, in the order as distributed. Well, no, the order is not distributed. So what happens is that the order Kafka. Pardon?
It is based on Kafka.
To tell you the truth, I don't know what's in 1.1 because there's a lot of changes. In the prior in Kafka, what's happening is that in 2.5, that's not the situation. I think that's what we're talking about. We don't use Kafka in 2.5. Or sorry, 2.0. So there's kind of a difference in that. Also in 1.0, if you notice that, let's go back to here, the CAs are actually on the order, right? Now what they've done is that they separated in 2.0, that they actually separate the CA files from that. So there are a lot of differences in there. And also you notice that the consensus, they didn't have, well, I think they have RAP, but they didn't have Byzantine fault tolerance. So that's a consensus difference. Yeah.
I mean, all the everything is to be endorsed.
Yeah, so back to the question that was on there, that's all I was saying was that it's a decentralized architecture. So what you guys are talking about is correct. And it's also this can be stored on different independent, it can be distributed. But that's originally what I was saying was that the failure of blockchain is not the technology, it's really the governance, right? So what's happening is that there's a lot of entities and companies that are saying, well, how can we capitalize on this? and they're not really taking the essence of blockchain and saying, well, yeah, well, it has to be decentralized, has to be transparent, so on and so forth. So you are correct, it could be distributed, but that has to be included into the architectural design of it, right? All right, so yeah, as I said, as the technology becomes more mature, people are going to get educated. If you look at the 2000s, a person that knew how to do HTML or even know basic HTML was earning about $100,000. And now, I guess a 5-year-old kid could do the same thing, right? Because it's becoming general knowledge. And eventually what's going to happen is that's going to happen also blockchain. People are going to start understanding the basic technologies, so on and so forth. It's going to be general knowledge. Also, there should be more standards that are going to be created. So when we have more standards, good practices, people are going to understand what to do and not to do, what to expect. Also, more libraries right now, it's kind of difficult to work with a CLI to pretty much your creating configuration deploying. In the future, I think we had Docker Composer before, but the project stopped. In the future, what I'm predicting that there's going to be probably an interface that's going to be enabled to make it much simpler that you're going to deploy organizations and configuration for the interface friendly interface friendly integration. And as I said, it's in the stages. So I apologize if I made any mistakes, but that's the end of today's presentation. Before we end this off, I guess if there's any questions or any questions from online.
So on every node that you create, you also will require invest on hardware as well.
Hardware in terms of
the server, you say? Has to be
Yeah, okay.
servers.
So if we look at this, right? So if you're talking about this network here, that network is going to be maintained by the admin, right? So that's maintained by the admin. So all the processes and so on and so forth is maintained by the admin. What if you just join the blockchain and you're not creating this? What's going to happen is you're going to have a copy of the ledger, right? And through the SDK, what you're going to do is you're going to make transactions, right? But okay, so you're going to make the transactions through the SDK. Do you get that? So really, even though this is the admin, it is difficult because you have the policies, right? The endorsements and the CA are connected to that server, right? So when you configure this, it's going to be configured to this, to the IP address of this. So when you get the CAs, it's not just, it's a lot of other information included with it, right? So in the configuration is going to obviously is going to define the IP address, the configurations are there. So for example, you have any IPS project running. Currently, I believe that there is. There's test environments of those. But in terms of production or something live, I'm not sure. Right now, I've noticed that a lot of the projects are just in test mode. For example, I'm still seeing quote-unquote production level Hyperledger using Docker, or they're using CryptoGen to create the CAs.
To verify me the Hyperledger project.
Pardon?
Verify me the Hyperledger project. Verify me. You know, when you purchase something, then you go to the security chat.
Yeah.
Right. That's the Hyperledger project.
No, I'm not saying that. What I'm saying is, no, obviously, you have we trade Tracelands, there's a lot of projects out there. Right? I'm not saying there's no projects out there, I'm just saying that the IP is there's probably a project out there, right? But what I'm saying is I'm not aware of an actual project that's actually there are currently. That's the IP system. But I do know that there's actually we're working on one right now that's integrated with the IP system. But right now, I'm not currently. But sorry, did I answer your question? Or? Yeah. Any other questions? So last time, I guess, any other questions from the chat? Yeah. Okay. So. Yeah. So yeah, I guess I did answer that question. Can we just in a sense that it could be distributed through decentralization of having the nodes on different, what do you call it, nodes. But again, then again, the two nodes can conspire together. But then again, what should be concentrated is the governance of it and how the network is governed and how the policies are made in order to secure the system. All right.
May I have your attention, please? It is now 8:15 p.m. and the library will close in 15 minutes. If you're borrowing library materials, please use the nearest expression book to you. The library's computer equipment will shut down at 8:25 p.m. If you're using our wireless service, please end your session in 10 minutes time at 8:25. Once again, the library is closing in 15 minutes at 8:30 p.m. Thank you.
Great. Again, sorry for the interruption there. Sukhpreet, thank you so much for your talk. I think I can speak for everybody here tonight and say that it was very informative and insightful. So thank you again. And to everybody here tonight, thank you so much for attending tonight. We appreciate everybody being here. We appreciate your participation and all the questions that you have asked. Again, I apologize if we had some technical difficulty and to the people who are online. Again, we had some issues, but hopefully we'll get it right next time. So again, thank you so much. Thank you for coming and just look forward to our next event. Like I said, it's in March and we'll get that information out through our channels to you. And then we'd like to see you at the next event. So good night. Thank you. And we'll see you again. Take care. Bye.
Thank you so much.
You guys work on the zero knowledge corporate, right? No.